So now in this session we are going to see about second law of thermodynamics. So we have seen the first law of thermodynamics, which is the generalization of law of conservation of energy. So is second law a different law or just it can be derived from the first law? This is the fundamental question we must answer. So the first law tells that the possibility of usage of an energy, that whether this energy can be used in this form or not. So when I relate work, heat and internal energy, then we have seen how that energy can be used in a different process. This is what we talk about first law. For example, so the first law tells that if energy has to be supplied to a system, that can be done in two ways. Number one, just supply heat the system and automatically energy will be supplied. Next way of supplying energy is that do some work. Either you can do dissipative work or you do some configurational work to the system. There are both ways in which energy can be supplied. Now it's the same thing I am talking in a common language. In a common language, the first law can be explained like that. Suppose in kitchen, the mother cooks rice. Suppose rice, we want to prepare rice. There are two ways to prepare rice. We'll put rice and water in a pressure cooker and then we will put it on a flame. That means we supply energy by heating it. So by supplying energy, we can prepare rice in the pressure cooker. Now there is another way by which we can prepare rice. Now we will put some rice and water in microwave oven, and so again in this way, by using microwave oven also we can cook rice. Now this is again we got the same energy with the help of work done. That means while we prepare rice in a pressure cooker, we supply energy to the food via heat. When we cook in microwave oven, we supply energy to the food system by the help of work done. So first law tells that energy can be supplied in both ways. Now what is the necessity of second law? Now we have seen that 100% of heat can be converted, 100% of work can be converted into heat, but 100% of heat cannot be converted into work. Some work is lost. So although first law claims that heat and work are different form of energy, we feel that 100% of work conversion into heat is possible, but reverse is not possible. We can't get 100% of work converted into heat. That means some other law of nature is prohibiting the flow of energy. It is allowing the conversion of work into heat, but disallowing the conversion of that heat into 100% of work. So the directionality, the way in which the energy can be used is predicted by second law of thermodynamics. So first law predicts whether this energy equivalence is there, but second law tells the direction, the way in which energy can be used. Now let us see how we got the idea of second law. So what happened? Previously, our ancestors did a lot of work in the field of energy conversion, efficiency and all those things. So let us see a Gedanken experiment. Let us imagine an aeroplane moving in air. Now what aeroplane does? It takes heat from the atmosphere, the air outside it, and uses that heat into work, and so it can fly. Next example, let us imagine a ship. That ship has an engine which uses the heat energy of the water and then it converts into work and sails throughout the... So in this way, it does not require any fuel. So is this engine possible? So we have tried a lot of experiments where finally we concluded that we can't make such a engine. So finally we concluded that some law of nature is prohibiting us to make such an engine. Now we know that we can't do that because we can extract heat from the water of the oceans, but we can't throw it. We don't have the sink. Similarly, when the aeroplane flies, it can absorb heat from here, but there is no sink where it can throw the remaining part of heat. So the second law of thermodynamics prohibits us, does not allow that formation of such an engine. It tells us a particular way in which things can be used. That means it provides directionality to a change. It provides directionally to the use of energy. Now let us see one more case. Suppose I am having a cup of tea. I am taking a tea, and suddenly the tea falls and the cup falls and it breaks into pieces. The whole tea is shattered here and there. It is on the floor, and the whole of this event is videographed by a video camera. Now what is happening? Now I play this camera in a reverse order. So what you observe, first you will observe that there are different pieces of teacup. The tea is spilled over the floor and automatically it is arranged and it goes up and it forms a cup, and then I am drinking it. When you will see this video in reverse order, you will feel that this is not possible. Let us see another set of experiment. Suppose I am standing like this and suddenly I had a fall like this. So suppose I fall like this and the whole event is videographed. Then what happens? If you play in reverse order, you will see I am falling, I am on the floor and I am moving like this. So automatically you will recognize that this event is not true. So now you recognize that this event is not true because in your mind there is a sequence of events. Now the same event I plan in a different way. Suppose I have a ball, a crazy ball, a super ball, and I let it fall. It collides with the floor and rebounds to the same height and makes up and down motion. So let us assume there is an elastic collision and the ball comes and goes on. If we record this event and play in reverse order, we will not be able to tell whether this is forward motion or this is reverse motion. So there won't be any difference. That means in nature there is a sequence of events associated with all events. So the sequence of events, that is the way in which it will happen, is what is predicted by second law of thermodynamics. It tells that the sequence is this. This is the way in which the system should behave. So we will learn now the second law of thermodynamics in different context, in the form of, in the language of engineering, in the language of refrigerator, in the language of engines, and finally in the language of entropy, which we will see after discussion on the Carnot's cycle. So entropy, where we talk about randomness, orderness. So let us just explain that orderness and disorderness. So now when we talk about work, why work can be 100% converted into heat and why heat cannot be converted into work? What is the difference between heat and work? First law tells that they are same thing, that is energy, but the second law tells no, they are completely different thing. So in order to explain the difference, let us view that we are inside a classroom. I am the lecturer and there are so many students in the class, and one student is having birthday. He comes to me and says that today is my birthday, can I distribute chocolates to all the students? I say yes. So what happens? He distributes chocolate to all the students. All the students get one, including myself, and in this way his birthday is celebrated. Now suppose the lecturer is not in the class and suddenly the boy announces that today is his birthday. So automatically the students are very enthusiastic, they are very smart. So the nearby students and their close friends, they take more number of chocolates, and so some students will get more number of chocolates, but some students will get less number of chocolates or sweet, and some will get none. So in both the cases, the same number of chocolates and sweets was distributed in the class, but in the first case, when the lecturer was present, the distribution was uniform and ordered. But in the absence of lecturer, the sweets was not properly distributed. Some of the students got more sweets, some close friends hijacked the whole plan and they took most of the sweets, and some got none. So the same energy is distributed in both the cases, but in the first case, in my presence, it was ordered distribution, but in the absence of the teacher, it was disordered distribution. So when I am supplying energy to a system, how we are supplying the energy into the system is very important. So when we do work, configurational work to a system, what it means, we are supplying ordered form of energy to each and every component of the system. The energy is orderly distributed. Whereas whether it is in the form of heat or dissipative work done, the energy is supplied in a disordered manner. Some gets more, some get less. So it is the orderness of the distribution of energy which will decide that whether 100% conversion is possible or not, which is actually the law of entropy, on which we will study in latter half of this lecture. So this is the basic idea, theme of the second law of thermodynamics.